Welcome back to my channel. I'm Brian Kafke, and this is lesson 12 from a video series, Master Databricks and Apache Spark, open source. In this one, I'm going to be focusing on using views, SQL views, on Databricks. The double brick icon indicates this particular video will focus on Databricks. When you see the Apache Spark icon underneath the lesson description, that indicates that it will be about an Apache Spark specific thing. The difference between them is small. Databricks is a wrapper around Apache Spark, but there are some little nuances, mainly because of features that Databricks is giving you, you may have to work around when you're doing Spark. In this video, we're actually continuing where we left off in the last video, and so we're going to have to repoint ourselves. At least in my case, I've let the cluster stop, so to get pointed back to the right database, I'm going to say use AW project. And that is the database where we loaded all of our CSV files to and then built SQL table descriptions on top of them. So we created SQL tables on top of these views. Very similar to Hive. In fact, it's using really Hive under the covers to provide that. So we can now slice and dice and query CSV tables. In our last episode, we did creating tables on Databricks to persist data so that we could query it and make it easier. In particular, we created a table, T_product info, which flattened out the 3 different product tables. So I'm going to continue the theme of making life easier by creating objects within SQL that will make things easier for us to do our data analysis and query. And a lot of it is about reuse. So what I want to do this time, instead of creating a table, I want to create a view. And I want to make it a little bit easier for me to use, in particular, in this case, dim customer, our customer dimension. So here's our dim customer table. And what we're going to do is just going to say create or replace view. And then going to give it a name, v_customer as. And then it's just whatever query we want to write, whatever SQL query. The biggest thing here is we're getting a subset of columns. We're not doing too much fancy here. I'm really more interested in showing you things that can be done. But we're going to rename the English education column to just education. And we're going to take this, we're going to change English occupation to just occupation. And most importantly, we're going to create a calculated column. What I mean by that is we have this column called birth date, which by itself is not terribly useful. But it could be very useful as a demographic when we're trying to understand buying patterns and what are people buying. Now, knowing that they were born on a certain date doesn't help, but knowing their age probably does. So what we're going to do is calculate their age by using SQL functions in a calculation. We're going to use in particular the function dateDiff. And by subtracting the person's birth date from a system date part of SQL, current date, which will always return the current date, we can get the difference in days. If we divide that by 365, we're going to get is roughly the number of years. Now then I'm casting it. This function int is going to force this value to go from a decimal to a whole number, and I'll call that whole number age. So it's pretty simple. It's not a perfect calculation. I could worry about rounding and things, but I'm just basically just taking it and making a number. So it may be not perfect, but it's close enough for what we're doing, and you're certainly welcome to find a better calculation. So let me run this and create our v_customer view. And I'm going to press Control Enter just to run this without advancing. That was pretty quick. Now the key thing about a view is it's always going to go back to its base table here, dim customer, and run the query again against that. In other words, I can treat v_customer just like a table. I can select, I can slice, I can dice, and do all those wonderful things, but it's always going to run this query automatically and give me the results, and that's actually what I'm slicing and dicing, but it's transparent. I don't have to worry about that. Now, in the last video, we created a table. The table, when we extract the data and put it in the table, it's fixed. So if the CSV file underneath the covers changes, we won't get the new data. But we're looking at dim customer. So if dim customer changes, we're going to get the new data from that. So this is always going to run the query underneath. And that's the difference between a view and a table. A view is really just a named query, but we can treat it like a table. So it can be pretty handy for that purpose, and it's nice too because we can change the view, and if there's a lot of data that would normally come back, we don't really have to reload it. If it were a table, we'd have to reload all that data if we were changing things. But this is just a query. All right, so we've got our view. Let's run a little test here, Control Enter, just to see a couple of rows come back using limit 2. And we can see, lo and behold, it came back here. And if we go to the end, we can see we have a couple of reasonable looking ages, so that looks pretty good. So this is good. We got some good stuff to start with. Now I'm going to take this concept and get a lot more complicated to show you not only the use of views, but the ability to use more complex things, such as the case statement, which is a great way to do like a series of evaluations and translate values. So we're going to return in this particular view. I want to do a view that will simplify my querying of sales info, so I don't have to keep redoing certain things that I want to use a lot. So I'm going to return from this view the sales amount from fact internet sales, all the columns from vProduct info we did earlier. That should be, let me fix that. We made that T, product info. DIM customer, get education, gender, yearly income, we're going to call it salary. Customer has any children. We're going to check that. And if they have they have children, which means number of children is greater than 0, then we're going to return a Y. So we're creating a new column. Otherwise, we'll just say no. We'll call the return column has children. From DIM customer, we're going to take the homeowner flag and just call it homeowner, because we don't need it to be that long. And we're going to do something kind of interesting. From the DIM customer, we're going to create a column called age band. We're going to take the age column that we created in the view, and we're going to put it into slots, because typically when you're doing, for instance, in feature engineering for a model, or even just in general analysis, individual ages are kind of difficult. You're going to have, if you try to do a bar chart, you're going to get a different bar chart for every value. That's not terribly useful. So grouping it into, say, 10-year bands probably makes more sense, because sort of in general ages, you might see some interesting trends. So we're going to do something like this. We're going to say, okay, where the age, this is popping around a lot, but where the age is, let me try this again. When the age is less than 18, we're going to return the word minor. When the age is between 19 and 29, we'll return young. Between 30 and 39, middle. 40 and 49, late middle. And anything greater than 50, we'll just call the golden years. And otherwise, if it doesn't meet any of these, we probably have bad data. We'll just return other. And they're going to call the new column age band. Now let's take a look at the entire query. It's a lot to look at. As before, we just start with create a replace view. We give it a name, the sales info as. And then we run our query. So this is our select statement. We've got a lot of different columns coming. Some of these, let's look at our first case statement. I mentioned we're going to look at has children. So it's probably easier when we're looking at like grouping things. Instead of 0 and 1, we can, or any number of children they have at home, we can just say, well, look, if they have a number of children greater than 0, they have children. So we'll turn this into a flag. When number of children is greater than 0, we'll return a Y, otherwise an N, and we'll just create the column has children. So that's going to be in the query. House owner flag, we're just returning as house owner. And this is the one we just kind of discussed. We're creating the age band by evaluating all of the different range of ages. So again, when you're doing this kind of case statement, use the word case, and then you just do a series of when clauses, when this, when that. It's a really powerful statement. I use this a lot in SQL. It's great when you have to translate codes or something and make something more meaningful. Pulling some other columns in here as well. We're bringing in a couple of columns out of the date dimension, which is kind of nice because we want to get the fiscal year and fiscal quarter. We can just join to the date dimension for that. We're pulling out the English month name and just changing it to month, and month number of year to calendar year. And you can see the tables we're pulling in, and this is still all inner joined, so we're just joining on the appropriate keys to bring in the customer, fact internet sales, T product info, dim date. All right, so that's about it. Let's run this. And that should have created a view. To summarize here, just kind of look at that. That's a lot of work. And if we do a lot of these things all the time, for instance, that age bands, that looks like something I'd want to use a lot, right? I'm going to reuse that because I may want to do pie charts. I may want to do bar charts. I could have dashboards related to this. And it's very likely something I would want to feed into some sort of a predictive model. especially the one about what are they likely to buy. So the age band is very reusable. I think also the number of children, it's a pretty simple thing. But again, I don't want to have to join all these things together and do all this work just to get this kind of information. By persisting it, I can now query the sales info, and I can do a lot of different useful queries off of this, and I don't have to do all this coding logic again. So reusing what we have. All right, so let's take a simple example of using this. We're going to use this vSales info. What I want to do is, a very common problem in data is that you don't have enough data or there's gaps. Any number of reasons for that. So let's see how much complete data we have in the system, in the vSales info that we just pulled in. We're going to look at fiscal year and the month, and we're going to count how many we have. So by grouping this and counting, we can get an idea of how many actual months of data do we have within a fiscal year. Now I'm using a new thing, which is kind of a cool thing called a common table expression. And we start that by saying with CTE, it could be whatever name. This is kind of like a view, but a view that is only used within a single query. So this entire block of code is really one SQL query. And what we're really doing is whenever you have a from statement in SQL, you could actually put parentheses and run a SQL statement in there if you wanted to. You can do a lot within that, and that's called a table expression. But when we separate it out as we're doing here and make it a separate query, which I said is a lot like a view, then we call it a common table expression. And we give it a name, and then we can use that in our from statement. Now why I like this is because I can take logic like this and isolate it and put it separate. Make sure it works. It's going to return here my fiscal year, month number, and account, and it's going to do this group and order by. And then it's really, I can treat it just like a table in my from, in my next select statement. And you can have a sort of list of common table expressions. One can use the other. So if I create one here, I can use it again and again until I get to my final query. When you get to really complicated queries, this is a great way to make them more readable and more maintainable. So kind of bear that in mind, because when you start to get into it, I did a lot of stuff with like accounting queries back in the day, and I found myself doing subsets and groups and a lot of conditions, and CTEs, as I call them, common table expressions, were a really useful way that I could keep it sane, so that when someone said, oh yeah, when you group this thing over here, could you just make this change? I'm not looking at this master mess of code. I can just go to the CTE in question and fix it. And when you use CTEs, again, as I mentioned, it puts it all together into a single select statement. The common table expression disappears once you use it in the final select statement. So it's only like a very temporary view in that it's just really a way to put it all together in one SQL statement. And I cannot really overemphasize the importance of writing nicely formatted, clean, and readable SQL code. I've worked with some incredibly complicated, hairy code that people have written, and one of the things I hate is when people do queries in from expressions. They do a from, and then there's a nest, and then you get another query, and then in that from, within that, they do another query. Common table expressions are where you can extract that and make it much more structured, much more clean, more modular. There's my plug for them. So let me run this, and we'll see what we get. Okay, so we can see here, we've got 3 years, and notice that we only have 12 months in 2012. And we can see how many rows we have, how many rows of sales we have. So we really don't have comprehensive data to work with. We'll have to see how this goes, but if we were trying to do sales forecasting, we may not have enough data. So this is one of the useful things you're going to want to do when you're querying and exploring your data. How complete is it? Are there gaps? Are there things missing? Okay, let's move forward now. Now let's do another query. Again, I'm going to use that same thing as a base, vSales info, and let's just run this. What we really wanted to do is get a feel for things. What are the education levels and products that go with that? In other words, is there a connection between the education level of person and the category and potentially even models? In this, we're just doing categories of what they buy and how much. So what we did here is we said, let's pick the education and the category, and we're going to get the sales amount. Now, we're doing what's called an aggregation query. This means we're rolling it up, which is a good idea, as I mentioned before, when you're querying something on a node, on the cluster, because if you have a lot of detailed rows, you don't want them back. This is going to return a small enough subset of data that we can bring it back to the head node, the driver. So we're summing up the sales amount, and I don't really want to see these decimals that I get back, so I round that. So I wrap that in a function, the round function. Both of these are SQL functions, which means they'll perform well. I'm going to rename this total sales so I can see it here. And yeah, and I'm going to group it by category and education. And so what I get is the total sales as an integer, because I rounded it. This parameter here says no decimal places. And I'm seeing it by education and bikes. So I can see here the idea, like, okay, people with partial college, a lot of apparent sales with bike sales, people with graduate degrees, accessories. Now it might actually help. Let me make one more change to this. It's always dangerous to code when you're demoing, but let's swipe this. Actually, what I want to do here is see if I can do this. It's a nice thing. Sometimes in SQLs I've seen you can't use this generated column name in the order by, but it lets me do this, which is handy. Now I did this. Let me change this to descending as opposed to, because otherwise I'm getting low to high. I really want to know what are our highest performing customers based on education. What categories do they tend to buy? So I can see that the highest category is actually people with bachelor's degree, and this is their highest sales, and they buy bikes. In fact, you can see no matter what it is, bike seems to be the big thing, because actually we're learning AdventureWorks is primarily a bike company. We can also see, though, that the bachelor's degree buy the most, partial college next, graduate degree next, followed by high school, and partial high school. So our sweet spot for this business is people with a bachelor's degree and some level of college seems to be the key there. All right, let's go down a little bit. So I think that gave us a little bit, and that's the kind of thing you want to do when you're exploring data. Now there's one other thing I want to do. I'm going to combine the usage of a common table expression with the case statement. And what I want to really show you here is what we can do. Now let me break this apart so it's a little more readable. What I want to do is translate country codes from our DIM sales territory table. The reason I want to do that is because the current sales territory country has full names like United States, United Kingdom, and I want to use a visual that you can use in Databricks notebooks, which displays on a map. But to do that, I have to get the data that I'm going to map to be some sort of ISO code. So I'm going to use 3-digit ISOs, but I have to translate it. So what I'm going to do is I'm going to say, go from DIM sales territory. I'm going to select, just pull out the sales territory key so I have that. And then I'm going to do a case statement. I'm going to evaluate sales territory country, and when the value is United States, return USA. When it's United Kingdom, return GBR, Canada, CAN, France, FAR, FRA, Australia, AUS, Germany, DEU, Deutschland, and otherwise say NA. Now there are actually other countries I believe in there, but I just didn't want to cover them all, and I'm not really that worried about the other countries. And you can see this is going to give me basically it's giving me a little mini table, if you will, that's going to be called CTE_country codes, which will have the territory key, but now it will have a new column, which is the country code in ISO format. To make use of that CTE, I'm going to be joining to it. So I'm going to be querying, get me the country code and the sales amount, querying against these sales inflow as S, and I'm going to join CTE country codes, okay, this, on the sales territory key, right here. And I'm going to filter out the NAs because I'm only interested in those countries I have in the code. So the NA gave me a nice tag that I could just filter that out. Let's take a look at what this does. So it's pretty cool. I can hover over and see the amount of sales in each country. And I can see that it looks like Australia is probably the best sales we have, followed by United States looks pretty good, and then Canada is fairly good. France is okay. I can't really tell too well, but it looks like maybe a little bit in Germany. Yeah, Germany does have some sales. France looks like it's a little ahead of that. So this is really useful but in order to use it, I had to transform the data in the columns. And these are the kinds of things you're going to need to do a lot in data analysis. So I just wanted to kind of highlight that. So the two takeaways, I want you to really kind of get your head around it. If you haven't used common table expressions, you're going to love them. This is how we use a common table expression. And it's like I said, it's like creating a little table within the query or a view within the query. And here we're using the case statement, which is really a powerful statement, something I use all the time in SQL to kind of do this type of work. Okay, now we may decide we're doing a lot of work with, for instance, the customer view, the V customer we have. We could just take that, now that we've played with the view and we like it, we could take it and make a permanent table out of it. So to do that, we're going to say drop the table if it exists, because I like to make code that is rerunnable, right? Won't break, because if it doesn't exist, it won't even try to drop it. I'm going to say create a table, T_customer info. And then I'm going to say as, and then I can just select all the data from V customer, so the view V_customer. And all that's going to do is it's going to run that. It's just going to take all that data and create now a physical table. And we saw earlier, by default, it's going to store it in Parquet format. So it's going to perform well, it's going to have the physical data. And the advantage of doing this over view is that where the view is always going to have to execute that query behind the scenes, the table doesn't. It's actually storing the data. So that's going to perform better in general. All right, we're going to do the same thing with, going to create T_sales info. We're going to do that by querying V sales info. And just to see that this really worked, do a little query of T sales info. That looks good. We have all the data. Now, I don't really need these views anymore. I've got the table. I'm deciding I'm just going to drop the views so I can just stick with the tables because they're going to be there. They're not going anywhere. I can say drop view if exists, V customer, and drop view if exists, V sales info. Great. And that's about it. But I'm going to leave you with one extra treat. You're going to love it, which is one of the things I don't see YouTube videos do is give you homework. But you need to practice this. You need to try it on your own. So I'm going to walk you through in the notebook. Go to the link, go to GitHub. You'll get the notebooks. You can unzip them and upload them into your Databricks environment. And I'm going to give you a little help here. I'm going to run this. This will give you a description of T customer info and T sales info. I find I never remember table, column names, etc. and types. So by doing this describe, I can refer back to it. Oh yeah, that's what I want. Now for your homework. Your number one question is going to be write a SQL query that returns the total sales amount. And let me fix the name because I misnamed it. This is actually spelled out, I believe. Total sales amount, the customer's number, and the customer's number of children. Okay, let me fix this again. Grouped by the customer's number of children. So you're getting the total sales amount from T sales info, and I'm going to call it total sales. We're going to group it by the number of children at home and T customer info. Do that. So that's the gist. And I've left you a nice cell that you can use for your own to write that query. So kind of, what are we really looking? We just want to get total sales by the number of children at home. That's it in a nutshell. And we can use T customer info. It has the data we need. Enter your code here, test it, see what you think if it's right. And down here, don't cheat, but you're welcome to. I sometimes just decide to look at code and don't want to be bothered. But if you want to try it, and I recommend you just try it, a little frustration is good because you'll figure out what is not clicking. But you can just click on show code, and that'll be my solution to the question. So you can go up there and do that. Number two, take the query you just did above, or steal mine, and round the total sales. Remember I did this earlier, so you can look above in the notebook. Round the total sales amount to a whole number, i.e. no decimal places. Then sort total sales from high to low. So you need to sort by the total, sum total sales. All right, you want to sort by that. Okay. And again, you can do that, or you can just go here below and show the solution. And finally, want to get what is the average sales by fiscal year by gender. So these are kind of exploratory things. they're not very in depth, but they're a great sense to say, okay, is there a difference? Does one gender tend to buy more sales than another? Some products, maybe men buy a lot more, and others women buy a lot more. So this is a good, again, sense of how is the company doing and that type of thing, and which customers tend to buy the most. So we're not going for total sales. We're going to use average. So again, we're going to use an aggregate function, AVG. I'm giving it to you. I'm giving you a little hints here. So take a look at what I write above. We're coming against T-sales info. We want to get the gender from, we have to join to T customer info, and we're going to use the rounding to round the sales amount to whole numbers. We're going to sort by fiscal year gender and average sales amount. Okay, and you're going to have to also group. So I say sort. Let me just I'll put this here just to make sure you know that. All right. You can enter your answer here or click on the code below. So I've got that. Kind of cool. Let me know what you think about doing some like homework assignments and trying that out, how it goes, because I'm interested to see. I think this is a great way to kind of make this process of the videos more interactive and more like a real training course. So wrapping up, covered a lot and almost all code. We only looked at one thing, which is using views, but also the types of queries we would do in views. So we focused on creating and using views on Databricks with Spark SQL, and I showed you a couple of cool techniques I like. One was the case statement, right? Using the case and doing the when clause so you can see, break out different conditions, and then translating columns so you can look at ranges or taking codes, and by different conditions you can return different values. It's a great way to create new categories and new types and things in your code. The other thing we talked about was common table expressions. I was actually surprised when I first saw that Spark SQL supports them, because they're really powerful. You can nest them, you can create a bunch of them and make some very complicated queries that are very easy to read. And that's my favorite thing about common table expressions. They're easy to read and they make code maintenance easier. That's about it. So please like the video above all else. Let me know in the comments what you think, what your questions are. Share, subscribe. If you subscribe, by the way, I always forget to say this, but click on notifications so you get automatically notified when I upload new videos. And by the way, also, if you want my book, you click on the link I'll put in the description. You can go get the book. It's riveting. Other than that, till next time, I'm pulling for you. We're all in this together. Thank you.